I lead engineering work in a very niche domain, I would say. So it's the hardware design domain. And our team is actually working at every step of the hardware design for our data centers. For those who don't know it, Meta is designing and operating their own servers. We're not offsetting that. So every year we have a bunch of new servers that we design and we deploy in our own data centers. And so this is what my team is doing. So a few areas I'm working on and what my team is doing in particular is so designing the new racks. This is a rack is a collection of servers, making sure they work and they work steadily on the fleet. And the last point is making sure they're sustainable across their life cycle. So from design to end of life. So today I wanted to emphasize really one thing is circularity is possible when we're able to measure and identify what component we can reuse. So in this context today, I will talk about circularity in the context of servers for our own internal reuse at Meta. So for context, I've been introduced to the network by Diego because I'm also the OCP lead for Meta. So OCP is a consortium, open compute project where many companies work together to change standards, the industry, and open source how compute hardware mostly, can be standardized so we can work together. So it also has a sustainability tenet. And one of them has a circularity work stream. And this is how we met because we're working together on writing the final version of a circularity ecosystem for data center white paper that should be out hopefully before the end of the year. And I will talk a little bit more about that later. So this is an overview of the strategy we have at Meta on the hardware side for sustainability in general, but also reuse. For us, we cannot reduce what we can't measure, and we can't measure if we don't have a common language and a common system to actually compare things between each other. Data quality and sustainability is generally a big issue across the board because of this lack of common language and because also of the issue of not being able to directly measure emissions for every component. So we have 4 pillars. The first one is standardize, creating this common language on many different domains, scope 1, 2, and 3, and also circularity. And this is why I'm here today, because for us, it's very important to collaborate, to make sure that we're working as an industry, because we also have shared responsibility depending on where we are on the supply chain, and we have to work all together. So the second is creating data systems for measuring and turning every component that we own into something actionable, whatever this something is. I will also talk about that later. Then design, which is a big program in our organization. We're thinking about 2 programs. One is Design for Sustainability. That is a very well-established program that we have at Meta. For every new server, we go through a certain process that I will detail a little bit later to identify what we can do to reduce our carbon footprint. Sometimes we can, sometimes we can't, and we're trying to be very honest about what we can and cannot do and push the research internally on that. And there is also another point that arose, I would say, last year, which is design for longevity. And this is also something I would like to introduce today, which is design for sustainability and longevity are 2 things that are good for the environment, but most of the time don't work together. Because when we make choice for longevity, we don't always make choice that are good for reuse in a very logistical and basically engineering problem that can block us. And finally, reuse. So it's more like end of life. How can we keep our hardware in service as long as possible, either internally or externally? So this is also something that we'll really think about. So in blue, I have highlighted also the network's value and theme, which are very naturally aligned with what we do at Meta. So I think it's a good day today for me to be presenting here. So for the why now, I think it's important to talk about that because we can wonder why all of the sudden all the hyperscaler are thinking about sustainability and circularity. So we've heard about my colleague at Google this morning. There is a lot of effort that they're doing. I would also like to cite Microsoft and AWS, with whom we work very closely. And there is indeed something happening right now, which is a direct correlation to the AI boom that we've all been observing. So the demand for AI is growing. And for us, what it means is very materialistic. We need hardware. We need hardware to a growth rate that we cannot just sustain by buying like an immense amount of components. And also not just because of a finance aspect, but also because before us on the supply chain, the manufacturers can't always provide what we need for our capacity. So reuse is not just a design or a sustainability constraint, it's also a demand constraint to actually meet our goal. The last point that I want to highlight is the front-loaded carbon. So that is, I would say, more like a accounting protocol more than anything else. When we purchase any component, so when I say component, I think about like CPU, GPUs, RAM, so very like materialistic idea. When we purchase that, we are responsible for the Scope 3 emission. So it means that the moment we buy, the moment there is this acceleration, this is the moment that we have to declare and report what is our Scope 3 emission. And so for those who wonder, every year we publish a sustainability report where this is all detailed. So it also means that we don't want to have a growing Scope 3 emission because we also have net zero goals by 2030. So we have to offset with circularity or other tools this issue of front-loaded carbon. So the first thing that I want to talk about is the standardization mechanism and how we're trying to create this common language. So I was talking about Google, Microsoft, and AWS because in the Open Compute project, we have created a group called the Product Category Rules that actually wanted to take the problem, the measuring problem from the source and say, how do we create this common language? And the first thing we realized by talking to each other is, when you talk about a GPU, what are you exactly talking about? Because if we want to do real circularity, I need to know what I can swap with what. And if your CPU or GPU is not the same definition as mine, it's not possible to either like externally reuse that. So for carbon accounting purposes, but also circularity, we have created a taxonomy that we are publishing by the end of the year. That's 2 publications from OCP by the end of the year, where we're trying to define exactly what are the components. And this definition really helps us understand where is the carbon footprint coming from. And we've been working on that for a year, along with other work streams on that PCR project. And right now we are in a public consultation phase, meaning that these category rules that we're creating are going to be shared with the whole OCP group to get feedback from manufacturers. Maybe some manufacturers won't be happy about our definition of what an SSD is. So we're collecting this feedback. And the long-term goal of this product category rule is to be pushed to Brussels to help on actually regulations, because we also want regulations so everyone can declare their carbon footprint the same way and have rules that we also internally can use instead of reinventing the wheel every now and then while something new is happening. So for that, we're working with Fraunhofer, which is a company and an institution actually in Germany, helping facilitating the regulation process. On the data quality that I was talking about, one big thing we have seen is that data can be extremely messy and very different depending on the source. So for instance, if we look at like what is your RAM carbon footprint, we can have 10 different sources from the same product. And the difference can be literally X 1000X. So it's a disaster when you actually want to compare. So we have created an aggregation system and a data quality scoring with our LCA specialist team from the 4 companies to try to harmonize what is something that we think is a good carbon footprint life cycle assessment, what is bad data. And our goal is really to move away from this common methodology that everybody has, which is converting spend data into carbon emission, which is very bad for, I would say, at least 2 reasons. The first one is, of course, market fluctuation, but the carbon does not fluctuate linearly with the price. And the second is the message it actually sends, saying that the only way you have to reduce your carbon is to spend less, which is completely false, and actually make some effort invisible, such as circularity. This is also going into the consultation phase. We are also consulting with PACT because our data quality scoring system is also built off the PACT system. So the next thing I wanted to talk about is, now we have good data. How do we internally use it to reduce our carbon footprint? So this morning, Adam had a very interesting way of speaking, which was AI for sustainability versus sustainability for AI. So this is where we flip the coin. So I heard a lot of conversation this morning about the benefits of AI and how we can use it. So this is one of them. So at Meta and every other data center company, we have a huge fleet of components. And of course, we cannot create a life cycle assessment for each individual component. It would be, I think we have calculated that it would take 10 years. So not possible. So we have created this process to estimate our carbon footprint at every single life stage of the design of new racks, including mass production. So starting with using the taxonomy, matching emission to anything we have in our database, and creating new carbon assessment using a portfolio of methodology that we have internally, and also that we learn from research. We're also very open to all the new publications on carbon footprint assessment for semiconductor. And then because we are embedded into the hardware, we are in the hardware design team, we work directly with the engineers saying, have you thought about swapping this component for this one? Because you would actually reduce the carbon footprint without changing your performance that much. And so we do that for every single stage. And of course, we track the emissions. So down to the component level and up to the fleet, which will then be used for our official audit and reporting. So doing that, we have learned something that was not that obvious when we started. It was actually the breakdown of what type of components were having the worst carbon footprint, or I would say the highest emissions. So coming back to what Francis was saying this morning, actually semiconductor is, because of all the work from mining, but also the processing, the laser, and the very, very energy intensive manufacturing process to transform that mineral into an SSD. And so it was kind of a surprise for us, and we're not a lot of companies sharing this because we thought the copper, for instance, and the rack infrastructure would have more impact. So now we're very, very focused on trying to work with our suppliers on semiconductor to find ways to reduce our carbon footprint. So like Google, we're also designing our own GPUs that we call that the MTIA. That's AI accelerators, parallel computing chips, basically. And so we're trying to leverage that to have more direct levers on where we can reduce our carbon footprint. So we have work in progress, hoping to share. And we are working with Google on how to share this data on another project that I will share a little bit later. So now let's talk about reuse. We have the racks, they're on the fleet. Let's say we have done everything we can to reduce the carbon footprint. So that's the horizontal, the vertical program. Horizontally, we have programs that are based on all the different categories of components and trying to create a systemic ways of identifying what components we can reuse. And so it's not that easy for many reasons. We have a lot of blockers. So I'll try to go high level on the blockers because, there are a lot. Especially for data privacy, which was one of the points that was highlighted this morning. So we start by a category, let's say DRAM. I will use DRAM as an example because it is actually the first type of components we have created this program around, and now we're using it for everything else. So is it safe for reuse? So meaning if we reuse this component, will it explode or create any issues in the data center? The second point, which I would say is a huge gate, is the reliability gate. So if I reuse this component, is it going to fail every day? Failing in this context means stop working, meaning that the server entirely can actually just bug and we have to repair what's happening. So of course, we don't want to select components that are unreliable. Then the TCO, which means total cost of ownership. So sometimes reusing components, especially when there is a technology break, means that we have to add an adapter or that we have to sanitize the component. This is additional cost. And sometimes it makes no sense to pay more money for sanitization or for reusing an adapter than just buying a new component. And so these components will then go back into remarketing. And then who needs this component? That is actually also a big breaker, which is completely tied to the design for sustainability program that we have. Let's say you want to reuse a component, but the technology break already happens. One example is DDR4. Now the companies generally use DDR5. So if you propose, I have a pool of available, let's say millions, so random number of DDR4 available. Do you want to use it for your new design? Sometimes the answer is no, it's not possible because this is designed for DDR5 and I cannot reuse it. So sometimes, and the lag between when we have identified a component for reuse and when it's actually possible to reuse can be several years. So this is also something that we have to work on. So I think I've already talked a little bit about it, but one big part of my team is working every day on reliability of the servers, not just for reuse and circularity, but mostly to make sure that our servers just work fine and properly. And so failures can happen for many, many reasons. Can be thermal failures, can be sometimes random issues, can be incompatibility that happens with firmware. So it is something we spend a lot of time on, and reuse is something that is, I would say, that's the main blocker. And this is also something that we're trying to publish about in the team. So with this framework in mind, I wanted to show some examples of what worked and what didn't work and where we are in our process. So it will be updated next year in the next OCP presentation. So DRAM works. This is what I was talking about. But we have different versions and different states, and we're also discovering a lot. So for instance, when I was talking about safety concerns, battery is one big issue because of the battery degradation. It can actually create issues in the data center. And we have other, like for instance, very basic pilots on reusing the frame of the rack. But that also means making sure the compatibility with the power bus is working and so on. So we're currently piloting that. And HDD, so disks, is also something that we're currently working on as a hack because there is a lot of additional steps for any data-bearing devices because we need to sanitize them. So we need to make sure the data is completely destroyed so we don't reuse something that has previous data from someone's Instagram account, for instance. And then you don't want that either. So one point here was the difference between design for sustainability and design for longevity. So at some point, it's almost opposite effects. And we're actually working on both at the same time. And so a lot of decisions are being made at the rack level, trying to see what we can do to optimize both. An example is something which is socketed, which can actually be taken off and on. versus something is good for reuse, obviously, but something which is actually soldered will be better for longevity, but then to actually reuse it is going to be an operational nightmare for all the facility teams actually on site. The difference between, as I was talking about for the memories, something that can be completely sanitizable versus we have to completely destroy it because it's not possible. If we reuse this component, we're going to have some data still lingering, which we don't do. And so in general, it's modular versus integrated. So the thing is, with AI, we usually go more into something that will last a little bit longer, which is also very good for our environment because our calculations have shown that compared to several reuse programs that we have, the server useful extension life program that we have is giving a lot of environmental benefits in addition to other short-term benefits. So I would say it's actually our highest program in terms of sustainability benefits. But if we still want to reuse components and making the life of the rack longer, we really have some engineering barriers that we have to work on. So another question, and I'm also here to talk about that to this room, is the question of the carbon credit. Because when we do reuse, the GHG protocol is a little bit blurred about what's happening at this time. So we are actually starting a new OCP work stream, trying to gather a lot of people to think about reuse and carbon accounting so we can propose something to the GHG protocol. That's the end goal, maybe in 2 to 3 years. We're just starting. But the problem is there are different schools. There is the amortizing school or you pay upfront for the carbon. But if you pay upfront for the carbon, it means that if you put it back into the market and you do all the sanitization work to put it back into the reuse market, you have absolutely no credit on that. And you actually own more carbon for all the work you've done to make this component reusable. So even internal reuse is not as simple in terms of carbon accounting because you cannot really say it's zero. So yeah, that's a little call to action and to brainstorming for all of you on that. So basically, generally speaking, companies lack incentives to go and work on reuse for semiconductor. And so 4 things that we're working on with the OCP ecosystem, but we're actually trying to open up this ecosystem is we need more regulation about helping multi-life cycle planning. So for instance, the warranty sometimes is just blocking us because when we lose the warranty of a component after, let's say, 5 years, it means that we're fully responsible for any failures. So all the engineering work to understand what's happening, we have to do that in-house, and it's significantly higher than collaborating with the manufacturer who can actually provide assistance. The second is universal qualification. So we do our own testing, grading, and there is no official certification for reused component. So for internal reuse, that's okay. We have our own system, but if we want to actually be embedded into a global reuse market, nothing exists for now. So there are some ideas coming here and there, but nothing certified. So the third point is very tied to the first one, which is new commercial models. So why the manufacturers, like let's say the DRAM manufacturer, won't propose something like if you extend the life, you have some benefits, or we can assist you more, or sell even an additional warranty for that. And finally, on the OCP side, so in Open Compute Project, one thing we do is creating open source specifications for our servers. So this is actually how OCP started. It's saying that hardware can be as open source as software. And so we will open source some modular design for reuse for servers so other companies can use what we've been doing. So I think the call for action is pretty obvious. At Meta, we are engaged in many different consortium. So we work with IMEC, for instance, which is a research institute in semiconductor sustainability, trying to understand how we can do better in reducing our carbon footprint. OCP is, I would say, our main lever of action because we're founding members, but also because we're very embedded in OCP. And we work with very targeted networks such as NIA, which is very, I would say, good for storage in particular. So I'm very welcoming for creativity and innovation in that domain. So if you have any semiconductor reuse or carbon reduction ideas, or even power optimization research and idea, we're open to hearing that. Thank you.
Lisa, I do have quite a few questions, but we don't have time for that, so I'm going to pose a couple. Just let me know if you can't see.
Yeah.
So the first question I'm going to ask you is around carbon and that kind of metric. There's questions on that. Is the emphasis on carbon over other materials? If so, how do you account for the mineral usage?
For the what?
Mineral usage.
Oh, that's a good question. I don't. We're reporting scope 3 emissions, and this is where regulation is actually important, because we're reporting what regulation is asking us to report. But we have all the work stream on, I would say, rare minerals, but I don't think it's reported in the sustainability report that we have.
Okay. Another question was, Gates' model was very clear. What are the biggest opportunities to reduce or address some of those barriers?
I think it would be on the data-bearing devices. If we can work together with the industry, and especially the storage industry, on how we can unlock a universal sanitization certification, that would really help us unlock also internally the risk of reusing some of these components. And reliability, of course.
Thank you. One more question. What are you most excited about in Meta's future in terms of sustainability?
I think we're doing a lot of things, to be honest. So I'm actually very, very excited about this consortium that we have with Microsoft, Google, and AWS. So we are going to push this standardization effort the further we can. And so hopefully adoption. Yeah, because I forgot to say that we will open source the calculation tools so everyone can use and calculate their carbon footprint the same way we do. And we will also we're working on that currently, to create a common database of aggregated components to make sure the privacy of our manufacturers is respected. But if you need industry averages of what, for instance, an HDD of X capacity, the database that we're creating will help. So I would say this is what I'm the most excited about, and seeing the adoption of that.
Thank you very much, Lisa. Okay, well, the round of applause.